All right, let's look at a few homework examples. I think the computations aren't hard in this section. It's just understanding what in the world they're asking you to do that's difficult. So I think 1 through 6 on your homework, we looked at examples that are similar to those in the previous videos. So I'll start with the 7 through 14 section. So let's take a look at number 8. 7 through 14, they say, show that this is a vector space or prove that it's not. Find a specific example to the contrary. And you can be using the ideas of null space and column space. You can be using the general ideas from 4.1, the 10 requirements of a vector space. So let's take a look at 8. And 8 says, apparently we're talking about R3 vectors here. And it says all R3 vectors of this particular format, 2 times R, or 3 times R minus 2, has to equal 3 times S plus T. And I'm like, okay, that's interesting. I can imagine that there are vectors that fit that. But immediately, I'm thinking they've got such specific requirements on R, S, and T that there's one specific vector that has to be there to be a vector space, which is the 0 vector. So I'm just wondering if 0, 0, 0 is in that set. If it's not, boom, that's it. We found a specific example to the contrary. So is it true that if R is 0 and S is 0 and T is 0 that this equation will be met? Let's see, that'll give you 0 minus 2, so negative 2 equals 0. Nope. Okay, that's it. We're done with number 8. We just checked to see if the 0 vector was in the set, and it's not. As soon as you fail one of the 10 conditions, it's not a vector space. You could maybe check some of the other 10 conditions too, but that's just the one that seemed easy to me. It's the one that came to mind first anyway. So another one from that same section. Just show that it's a vector space or find an example to the contrary. Here we're looking at R4, a collection of R4 vectors. And there's no little formula over here on the side. It just says P can be any real number and Q can be any real number. This feels a little more solid to me. But let me just check that 0 vector again. That worked well for me last time. So let's see if 0, 0, 0, 0 is in the set. To get a 0 in the last spot, that would force Q to be negative 1. However, to get a 0 in this spot, that would force Q to be 0. Q can't be both those things at the same time. So there is no P and Q that you can pick here that will give you the 0 vector. So this one's also out. I realize both my examples failed on the 0 vector. That's not true for all of the examples in your homework, but it's always a good place to start. It's an easy thing to check. Okay, let's take a look at number 16. 15 and 16 say find a matrix A. So when they say A here, they're talking about a matrix. And let's get on the right layer again. So they're saying find a matrix such that this set right here is the column space of A. And so this set says, hey, B, C, and D can be any, I don't know what happened to A. Oh, they don't want to use A because matrix A. Anyway, B, C, and D can be any real numbers, and you're picking them to produce this. So let me, and they're saying it is a vector space because it's the column space of some matrix A. So they're really saying these things come from B to B 0 plus negative C 0. So I'm just breaking these up by variable. 3C C plus the D's would be 0, 3D, negative 3D, D. And so that's still the same vectors. And just broke it up into 3 additions instead of a single. And I'm of course going to factor. So b times that vector plus c times -1, 0, 3, 1 plus d times 0, 3, -3, 1. Keep in mind the column space of A literally means the linear combinations of the columns of matrix A. So if you want a matrix A whose column space looks like that, also known as looking like that, also known as looking like that, it is the matrix 1, 2, 1, 0, -1, 0, 3, 1, 0, 3, -3, 1. There's an A whose columns you can combine to produce all of this stuff. Okay, so 17 onward for the rest of your homework. I think we've already done similar examples to those in the previous videos, and if you have any questions, as always, let me know.